Question number 38. A radioactive sample decays by emitting beta negative particles. The energy released in the decay process is the same for each nucleus but the beta negative particles emitted have a continuous range of kinetic energies. What is this? This is nothing but your neutrino hypothesis. You would have learnt in your theory classes, right? What is neutrino hypothesis? When they did the experiment, when they found out the types of decays, what are the characteristics of it, they found out when you plot a graph of energy of an alpha particle versus number of alpha particle, number of alpha decays, they found out that you got a straight line here, which means what? Every alpha particle when it decayed, it always came out with the same kinetic energy, which was seen to be 5 million electron volt. But if it is a beta particle, E beta, and you do the same experiment for here also, number of beta decays, then you did not get a curve like this, but instead you got a curve like this. What does this tell you? See, here you got some negative, some kinetic energy of the beta negative particle. Here it was highest, here it was some average, and incidentally you look at this point, this energy of the beta particle is 0. See, though you get a beta particle, but still the beta particle does not have enough energy. So which means what is happening over here? Why some particles are getting more energy, some particles are getting less energy? That was the question. So towards it, then, to explain this, Wolfgang Pauli introduced a new particle known as neutrino. So what does it tell you? It tells you that when a beta particle is emitted, antineutrino is also emitted in such a way that the energy is being shared, but the charge is not shared. Okay, that is where gives rise to neutrino hypothesis. Now let us read the option. Which statement explains the beta negative particles are emitted with a continuous range of kinetic energies? Okay, so the energy of beta negative plus energy of the antineutrino is equal to a constant. If you take up these two energies and plot a curve, again you get a straight line like this over here. Some of the energy release is given to the remaining nucleons in nucleus. No. Some of the energy release is taken by the emitted antineutrino. This is the right option. Some of the energy release is used to create the beta negative particle, create a new nucleon. No. So B is the right option. Okay.